In this lecture, we'll discuss about SR non-gated NOR latch. Okay, so in this we need two input NOR gates. Okay, one thing we have to observe comparing to NAND latch. Generally, in NAND latch, straight to the yes we write a Q, but here straight to the yes we have to write Q bar. That we have to observe. Okay. Some people assume this inputs as SR or XY also, and outputs as Q bar, or we can name some other names also. Here I named as Q1P. This P is nothing but Q bar here. Okay. So these are the constructional details. Now we'll see the operation step by step. So this is the truth table. Here SR two inputs and we will get 4 combinations. Okay. So here I have not started with 0 0. As I started in SR NAND latch with 0 0. Here I not started with 0 0. Okay. Because the reason is NAND latch will be in invalid state when we apply 0 0. Okay. So if we want to make it valid or useful, we should change any one input. Whenever the inputs are 0 0, even we feedback output many times, it will be it will maintain same output. Okay, we cannot go to valid state from the invalid. Okay, so here in a NOR latch, if we keep this circuit in 1 1, when we apply input 1 1, it will be invalid. Okay, so whenever we want to make it useful, we have to change the input values. Okay, and one more reason, suppose if initially if I apply 0 0 to the NOR latch, what will happen? We don't know second input. Suppose here if I apply 0 0 here, I don't know second input of each gate. Then I cannot predict output. Okay. Because there is no output also at that time to feedback. Okay, so we have to start from 1 1. Okay, so even with 1 1, even there is no second input, we can predict the output based on the NOR gate definition. Because in NOR gate, if any one input is 1, output is 0. Like that we can predict. Okay, and here you can see I taken Q here, Q bar here. Okay, these are the state names. Okay, now we'll see this operation step by step. So initially input both are 1 1 inputs. Okay, output is 0 0. Okay, this is invalid. I told now both outputs should be complementary. Okay, so you have to see this lecture after watching SR NAND, then only you can understand it properly. Then coming to second condition, S equal to 0 or equal to 1. Okay, so here I have started immediately S equal to 0 or equal to 1. Observe this. Okay, now 1 initially in first case I am getting Q bar 1 Q 0. Then when I feedback with the same input maintaining, when I feedback this case 1 outputs, I am getting Q bar 1 Q 0. So it is stable output. So I am taking this as final output. See here what is coming? When S is 0, Q is 0. When S equal to 0, Q equal to 0. This is called reset because this is my Q. 0 is stored. Okay. And here you have to observe in SR NOR latch, output will be same as S, but in NAND latch, output will be same as R when inputs are different. That you have to observe. Okay. Okay, now we'll see next condition, third condition. So here my S equal to 1 or equal to 0. When I feed back the previous condition output, I am getting in case 1, 0, 0. So I have to look for stable output. So I again fed back with same input maintaining. Then I got 0, 1. It means Q1, Q bar 0. Then again, in third case, I maintained same inputs and fed back the second case, third condition, second case outputs. Then it is maintaining same. So it is stable output. So I will take this as the final output for condition 3. So when S equal to 1, Q is 1. Q is 1. Okay. When S equal to 1, see, when S equal to 1, Q is 1. So it means 1 is stored. It is called set. Okay, right. Then last condition. Now 0, 0 I am applying. So when I fed back, I got 0, 1. And when I check for stable, I got 0. So this fourth condition output same as third condition. So this is called hold. So when I applying 0, 0, circuit becoming hold. So when we compare NAND and NOR latches, so when we apply 0, 0 in NOR, it is becoming hold, but in NAND it will become invalid. And here when we apply 1, 1, NOR becoming invalid, but NAND become hold. And when we apply S0, NAND becomes set, but it is becoming reset. And NAND become reset when we apply S equal to 1, but this is becoming set. So these we have to observe. Okay, right.